Why can a capacitor block DC and pass AC? I used a signal source to generate a sine wave signal with a frequency of 1 kHz, a peak-to-peak value of 3V, and a DC bias voltage of 5V. You can see that the sine wave signal is all above 0 Hz. Then the sine wave signal is connected to this circuit to measure the signal waveform on the resistance of this circuit. You can see that the sine wave signal with DC bias voltage, after passing through the capacitor, only has an AC signal left, which is this blue waveform. The blue one is the signal waveform on the resistance. The top is positive and the bottom is negative, while the DC bias voltage of the input signal disappears. In fact, it is the characteristic of capacitors to block DC and pass AC, that is, DC signals cannot pass through capacitors, while AC signals can pass through capacitors. So why can capacitors block DC and pass AC? It is mainly because the size and direction of AC signals are changing, which will cause the capacitor to continuously charge and discharge, so that we feel that there is current flowing through the capacitor. In fact, the current has not flowed through the insulating medium in the middle of the capacitor. It is only the accumulation and discharge of electric charge on the capacitor plate that forms a current. This is the AC transmission of capacitors. After the capacitor is charged with DC signal, its size and direction will not change, and the electric medium in the middle of the capacitor is insulated again. At this time, we can regard it as an open circuit, so there will be no current flowing through the capacitor at this time. This is the DC blocking of capacitors.